Hey, good morning, everyone. Good morning, good evening.
Hey, how are you?
Hey, doing good. Thank you. How are you?
Good.
Okay. Let's give a minute more, maybe for other folks to join in. Meanwhile, I'll pull up the pages, pull up the wiki page. Shiv, are we ready with some sort of discussion? What we discussed in the last call?
Yeah, sure, Rahul. Yeah, I have that. So I can discuss that. Yeah.
Okay, I'm going to just share my screen. Meanwhile, we wait for other folks to join in.
Yeah.
All right. I think it's early US time, right? So I'm not sure if we can expect. We don't have many folks joining in from US, is what my understanding is. PST time zone. Yeah.
Well, it's 11 o'clock. It's the perfect times.
Yeah, yeah.
So,
Actually, it works better for us as well. I'm located here in India, and it's
but
it's yeah, 8:30 p.m. Hmm.
California may be a little early.
Yeah, yeah,
Three,
yeah.
yeah, but not
Correct.
bad.
Yeah, it's what? Hey, it's 8 a.m., right? So it should be okay.
Yeah,
8. Hmm.
yeah.
Okay. Right. Let me just go through the task list quickly. If there's anything, I don't think we have to provide. Yeah, I think this is already done, so I'm going to mark it. This is going to be an ongoing discussions with the RX scope working group. I couldn't join the last meeting. I'm not sure if there was any discussion in the context,
Hmm.
uh, but I was not able to join the last meeting. Mm. Just another one point that I would like to bring to the notice is that we have the dashboard score should be improving. I don't know why this change is not reflecting. So we have 6.5 score here, and it shows still 36% here, but the score has already changed in the in here. So this is something that needs to be checked, why this is not why this is not reflecting. The score is right now 73%. And most of the fixes were done primarily by Ved. So credit mostly goes to him. And the some of the other things like security policy and all those things, having a way to for external users to disclose vulnerabilities in Nephew was one of the primary thing. After that, the score is improved. Somehow this score is not reflecting here. I thought it might be a weekly thing, so I was just waiting for this score to be updated here, but I still see that it's not updated. So anyways, I'll look into this. So this is one of the updates from our regular security best practices track. And that's it. Nothing else from my side. Anything else that anyone wants to talk about before we hand over the mic to Shiv? Shiv, do you want to go ahead?
Yeah, sure.
I think just to set the context, in the last call, it was discussed. How would UPF identify itself as UPF and SMF identify itself as SMF, and why other workloads won't be able to spoof the identity, or an attacker won't be able to spoof the identity. What are the concepts that SPIPI internally and Spire control plane internally leverages to establish that identity? I think this was the point that was brought up by Wim, and we discussed that this is something that we want to nail down on in the next call. And I hope Shiv, I'm on the right track here.
Yeah, Rahul. Yeah. So, am I audible?
Yes, you are. Yes, you are. I can hear you.
Sure. Yeah. Let me just quickly. So I'll give a brief overview of the Spire SPIFI concepts which are there, and then that will set the tone for the discussion. So we have a concept called node attestation, where the attributes of a node are verified. And so basically, let's say in a given cluster, we've got 10 nodes. So all those 10 nodes need to be attested and verified, basically with the Spire server. And then we have a concept called workload registration. So here we tell Spire how to identify a workload and what SPIFFE ID to give it. For example, I've just used over here ID 1, but then this is going to be with the trust domain and all that stuff. But for just for understanding sake, we just say give ID 1 for all the pods with the name UPF. And give ID 2 for all the pods with or a pod with name PCF and so on. So that's how we need to do registration of a workload. And then finally, there is workload attestation, where we actually verify the attributes of a workload. Like, for example, if a pod says, give me a identity, then we need to verify that the pod, that particular entity which is asking for an identity has got a given pod name. So that is the verification part. So we'll just run through each of these in some amount of detail. And I think by the end of that, we should have some clarity in terms of, how do we ensure that, two different pods don't land up with the same identity. So this is a diagram for node attestation. We have a Spire server which is running over here, and we have an agent which is running on every node in the system, right? And we have a plugin based on the type of attestation which is done. So for Kubernetes, there is a type of attestation called projected service account token. So the basic idea is that the agent needs to send something to the server, which sort of is a proof of its identity. So in this case, we have a projected service account token, and then that is sent across to the server as its proof of identity. And then the server basically does a token review request of this service account token with the API server. And then if the token review is successful, then the agent gets an identity. So this is a case where the agent needs to get an identity, and before a workload gets an identity, all the agents, the agent on which that workload runs needs to get an identity, right? So any questions so far?
I think this is an important point because like for the node attestation, making use of internal Kubernetes primitive would be important. Projected service account token is a step in that direction. But there are some gotchas there as well, I guess. So this is the attestation mechanism that needs to be, very clearly established. What is the best thing that will work in the context of Nephew? I have some thoughts here, folks, but this is the most important part. The attestation part is the most important part for any identity solution. So PSAT is one. Is there any other model that usually gets floated? I know for managed Kubernetes clusters, there are multiple models available. Like, you can verify with the managed Kubernetes provider, but for the unmanaged, like without depending upon any managed control plane, is there any other mechanism that is available apart from PSAT?
So from my understanding currently, Rahul, so there was one SAT option which was there. So now that has been deprecated with the PSAT option. So I can quickly, show that particular aspect. So yeah. So here are the list of attesters and which are there, node attestation and stuff like that. So yeah. So this is. So we used to have, one KSAT which was there, but now it's deprecated from the Kubernetes in a Kubernetes environment, and the recommended one is the projected service account token. So yeah, there are in other managed environments, as you were saying, GCP and all that, AWS and Azure, there are node attesters which are there, but I just wanted to illustrate that mechanism, and I think just to illustrate this,
Yeah.
use it over here. But yeah, definitely, I think this is a separate discussion in terms of which is the correct node attestation to use. But then, yeah, but for now,
what is the projected volume? What is that? That basically you write
yeah,
the volume
so,
on which you
yeah,
write.
So Vim, basically, what happens is that apparently the default service account token is something which is not the correct thing to use now. Like, for example, I have this particular blog which is there, which talks about that previously used to have legacy tokens, which is basically the standard default token which used to be used. But then now the way to do it is basically use the problem with this is that because these tokens don't have an expiry, and the way they are distributed also, that is there in the container file system. So now we have something called bound tokens which are available, and these tokens are basically located as in, so there is an audience, and I think there are other token related aspects which are there. But then the way this token is available in the pod is basically through this mechanism. So we have there's a project.
But Shiv, there is a fundamental difference here. You're talking about service account tokens which are namespace scoped, and this is about node attestation, right? Like, so I don't think service account tokens can be made use of for node attestation itself.
No, in the sense that because no, so here, okay, here is the thing, right? So I get your point, but basically in which, see, the spy agent is also running in a pod, right?
Yeah.
And so to that extent, it has a projected service account token. That's my understanding.
Yeah, projected service account token operates at the node level. So which means that basically when a kubelet is kubelet connects to the API server, a service account token is projected onto for that particular node, and it establishes the node identity. But again, I think there are some quirks that it has to be explicitly enabled in the control plane. I think there is yet another mechanism that we can make use of in the context of making use of cluster APIs. We are already dependent upon cluster APIs. Cluster APIs could form a good basis for foundational basis for our attestation, at least from the network perspective, from the node attestation perspective, right? Like that can be a better model. I need to check if anyone else has used that particular model. If you can do
yeah, definitely. So here, this is a node attester, Rahul, in that sense that, so it's specifically over here. So it is a node attester and it is using PSAT. So that's the one. But I get your point. So your point is basically service account tokens are basically namespaced, and how can you use it at node level, right?
No. PSAT is different. PSAT is different from the service account, standard service account token.
Yeah, right.
Yeah. Okay. Yeah, I'm clear about that. Yeah, that should
sure. Yeah. So then you were having this one, in terms of this one, right? What is this? So this is a token which is available inside the pod, and the spy agent is itself running as a pod. So this is a way to verify the node on which that particular pod is running.
Okay. Okay.
That's I'll confirm that, but that's my understanding.
Okay.
And that is available in all the pods. So there is a volume in all the pods that allow you to, where that volume is mounted into to check whether the identity is of the node on which they're running is okay.
Yeah, right. And this is what is provided as part of. So if you see this one, right, the agent configuration. The agent configuration typically will have this sort of a thing, where so just saying as it is a projected service account token will generate the necessary volume. So this is projected volumes. Apparently, there is a feature in Kubernetes, and using this projected volumes, these tokens are available. If you just add this volume mounts and volumes in the configuration.
That's for the agent, right? So the agent keeps track of the.
Exactly. So here, the agent will get the PSAT over here, the yeah, so the agent will get the token and it will send it across to the Spire server.
I think the aim here is that Spire server should be able to independently establish that the PSAT indeed belongs to that node, right? Like that's the whole purpose.
Correct,
And
correct.
Spire agent gets, so yes, it is mounted within the Spire agent, because the Spire agent will have those particular that projected colon spec manifest specified within the pod itself, right? Hence, it will be mounted automatically within the Spire agent itself.
Yes, that's correct. So since it's mounted, the Spire agent can send across the token, and the Spire server then uses the token review request API to verify that Spire agent is that's a valid token. So this is a verification which happens, this loop.
But the Spire server in this case, does it run on the same cluster or it doesn't matter?
It doesn't matter. I'll come to those specific, I'm just trying to set the context for what is node attestation, but then where exactly it runs, I'll just introduce that in probably a couple of slides later. But then it can.
But in other words, I mean,
because,
if you are a node, right, you get a PSAT, if I'm understanding correct, right?
Yes, yes.
So that volume is mounted. So in that volume, you have a certain identity, a SPIFFE ID, right? That
not a SPIFFE ID. It's a normal Kubernetes service account token.
Okay, it's a token. So you get a token for that particular thing.
Yes.
And you're basically saying, this is me, right?
Exactly, right.
And then 3 is token review of the PSAT. So you basically send it to the server, to the API server.
Is this a PSAT which is coming from your node? That's what we are trying to confirm that. So because
and what does the API server do to check to?
Yeah, so the API, so this PSAT is basically signed using some API server keys. So that's why.
Okay, yeah, that's the piece that I was missing. Okay, yeah, that's what makes sense. Yeah, okay, yeah.
Right.
Okay. Shiv, quick question. What's the connection if we get the node certificate from operator signed certificate, not the Kubernetes issues? And what's the changes? For example, Spire agent can use the node certificate, which can come from Kubernetes. I think your case is doing this, and all operator signed certificate. So that means the bottom line is Spire agent use the node certificate for the node attestation, right?
That's correct. So there's some certificate signing, which is, it's done. And this is a feature which is offered, coming boxed with, it's already available in Kubernetes. So yes, I think we can use other certificates and then probably use it. But then this is some feature which is already there. So we might as well. And this is what is supported in the existing, plugin provided by Spire itself. So
okay.
So yes, basically when you install Spire server, right, like you get a self-hosted, an internal CA as well along with it. You can replace that with the certificate authority that you trust, and the tokens the certs will be issued from that particular certificate authority. That is completely possible. Yeah.
Yeah, I'm okay, but I'm just talking about extension.
No, it is important. No, it is important because there will be requirements from users of Nephew where they will ask, we have a trust domain within the organization, within this vendor, and we want to associate all the clusters to that trust domain, right? Like it's a very formal.
So, but there's slight difference, Rahul, in the sense that one is basically the trust domain associated with Spire server, but this particular certificate on the node is basically the one which has to be signed by the API server because.
So PSAT is purely for attestation purpose, right? But once the attestation is successful, the cert provisioning happens, right? Like after that process is when the cert is actually provisioned, which will have the SAM.
I think what Byung is saying is that is it possible that even the proof of identity instead of a PSAT, can we have a node certificate given by the Spire agent? I think that's his,
yeah.
So it's possible. Probably we can make a plugin, but then that's something. It should be possible. Yeah.
Okay.
Yeah.
Thank you.
So so the identity which is given out by the SPIFFE, is of this particular of this particular attester is of this type, where you have trust domain, Spire agent, create a SPSAT, and there's a cluster name, and there's a node UID, right? So this node UID will come to the details, but somehow the Spire server is aware of the node UID also. So as part of the PSAT, which goes from here, we also send the node details and so on. And this is how the identity of the agent, this is how it will look like. Right. So moving on. So this is how the server configuration will look like. So we need to say node attester create as PSAT, and then we need to say what is the cluster and the cluster name. So if you remember the cluster coming over here, so this is what is there as part of the configuration of the server. And it says that from which service accounts can a Spire agent contact me, right? So we can mention, so this is basically the namespace and service account name from which the agent can contact me. And so this is the SA token for token review, in the sense that now if you see over here, if I need to send a token review request for PSAT to the API server, the Spire server itself should have a separate token for even launching this request, right? So that is this particular configuration. So is that clear? So we need one more token for actually launching this token review request. So either you have to have a kubeconfig, a full-fledged kubeconfig, or we need to have a separate service account token which is available for launching this token review request. Is that clear?
Yes.
Yeah.
And how is that identified, or how, that's during startup or what? Or
exactly, I'll come to that. So basically, so we need to configure that in the server configuration over here. So there is a caveat over here also, but I'll just come to that. But please bear with me that you need to have a separate token over here. Previously, it was a kubeconfig which was there, but then that will be too insecure for a requirement. So we need to have a separate service account token, right? And then in the agent configuration, so this is a projected volume configuration, which we have already seen. And then in the agent, we also need to say what is the cluster name, and then so this is the basic configuration which is there. So this completes the node attestation part of it, right? Now, whatever node attestation we have seen over here, this is one which is required if the Spire agent and cluster are in different clusters. In Spire server and the agent are in different clusters. If they're in the same cluster, we don't need to go through all that song and dance, and then we just need to configure only the server address and the server port. That's it. Right? So because you're in the same cluster, and we just need only the server address and port, and that's it. We don't need anything else, any other thing for registration. Sorry, node address.
what was the previous config? Can you show the previous config again?
Shiv?
Yeah.
Yeah. What about the, like, we were testing kube with kube config, right? If it's on a different cluster, is that different from this?
Yeah. So actually, so what I have done is that, so in the current, yeah, you're right. So basically, we either need a kube config or we need a service token for token review. So I'm using that service token for token review as of now over here.
Okay, so which one would be better to use?
No, so this is more secure, right? So instead of having an entire kube config over here to launch a API request, we'll be using a token which is only restricted only for token review. So in that way, it is secure actually. So, but then this is slightly more different topic. We'll come back to it.
Okay.
Right. So yeah.
But in the non-cluster, how do you get where is server address configured in the previous thing, or you're not showing it, I guess.
Yeah. So basically, what we say is that I've not added that. I've just used only shown the configuration which is actually required for attestation as such. But the location again we need to configure that. That's correct. Yeah.
But what you're basically saying is that the whole agent configuration like you have here is not needed. Is that right?
Exactly. Right. We don't need this volume mounts and all this projected service account tokens and all that. And so the reason is basically that is basically more of inter-cluster authentication, right? So because you have a service account token which is generated in a different cluster, is being verified by some other cluster. If they're in the same cluster, you don't need to go through that loops, right? Because you can anyway verify it in some sense locally itself. I think we can go ahead. I'll add some more detail, for the same cluster scenario. But I'm assuming that everybody's on board for the inter-cluster scenario. Is that correct?
Yeah. For me, it's not unclear why you would do something different, local cluster or other cluster. I would treat them all the same. But okay, that's a detail.
I'll come back to that, Wim, but in one sentence, right? So basically, now because they are on different clusters, the agent and the server, you need to have a separate token review again happening over here. If they are on the same cluster, then this proof of identity, so to speak, right? So that will get handled locally only. So that's my I'm just that's my understanding, because you don't need to do a separate token review request, because the Spire server over here itself will have the necessary credentials to verify this, whether it's a valid. So it's more like kubelet talking to the API server, right? So that sort of a scenario, and not on another cluster. But yeah, probably I'll come back to that. So now we come to the next topic, which is basically workload registration. So in workload registration, we need to basically register all the workloads which need a SPIFFE ID, right? And we need to say what are the SPIFFE IDs which match to certain attributes. Like for example, I need to give out ID1 to a pod with name UPF. Right. So that is what you need to do as part of workload registration. So
the quick question, is it per pod that you need to do it, or is it per network function?
Yeah, so it's per attribute. Like for example, I need to register workload entries, and they'll be registered at the server over here, and the server will push it down to the node actually. So all the entries are available over here. Now, the registered entries will look like this. It will have give out a service ID 1 if give out an SV ID 1 if pod name is equal to UPF, and give out SV ID 2 if pod name is PCF. I've just taken an example over here of a pod name, but there are other attributes are also possible over here. We can have a namespace, we can have a service account, we can have a container name, node name, and so on. So it's basically give out a SVID given a set of attributes. That's the mapping which is there as part of a registered entry.
Another thing is that the identity is not necessarily one-to-one mapping. Like for example, a particular workload, and that workload definition is not Spiffy says that if you want separate identity on per pod basis, it's up to you. If you want it on per workload basis, for example, daemon set or deployment set or replica set or whatever it could be, stateful set, you want it on per workload basis, it's up to you. So there are different attestation logics available in each of these contexts. So you pick up the right attributes to attest in the context, and then you can do that attestation. Another important thing is that a given workload can can be assigned multiple identities. It can be said you are X and you are also Y. You can operate with either of these identities. That is also possible.
Now we are talking about instance, right? Workload
No.
instance, right?
Yeah. So when we talk about workload here, right? My assumption is that it's a group of pods. It could be a daemon set. It could be a deployment set. It could be a stateful set, replica set, and things like that, like a high-level controller.
Just to take an example, right? Let's say I say over here, so give out an SVID 1 if node name is equal to, let's say, node 1, right? Now, so then all the workloads on that particular node will get the same SVID.
Yeah. But so it seems to be assigned to a set of labels, if you will, right? So you basically have a set of labels, right?
Exactly. Right.
I call everything a label. A node name is a label, in my view, right? It's key values. Let's put it that way.
Correct. It's a key value pair.
So you have a set of key values that identify a workload.
Exactly.
Now, the question is, if I am another workload and I use the same labels,
right?
what will happen?
Exactly. Yeah. So, so that's exactly what
well, you're coming there probably. Okay.
Yeah, I'm coming over there. Yeah. So I wanted to get this one out basically as to what is a registered entry and how do you map an SVID to a set of attributes, right? So I think now that's clear. So now when a workload is there, right? Let's say it's going to be a pod, right? And it says, give me an SVID. Now this call happens over a Unix domain socket, right? And it lands up at the Spire agent. Then the Spire agent basically looks up the pod ID of that particular PID, right? And basically, it looks up the C groups and all that stuff and figures out the pod ID. And then it launches a request to the kubelet, which says, get the attributes based on the pod ID, right? It pulls out this bunch of attributes over here.
Again, all this is for attestation purposes, right? Like this is for workload attestation purpose.
Exactly. Yeah. So yeah,
it needs to talk to kubelet.
So pod name, yeah. So it's the kubelet that makes it unique at the end of the day, right? Because a pod name cannot be. So there is a few, like container name, for example, and pod name is going to be kubelet assigned, right?
Yes.
And so as a result, you are going to, so that makes it unique, if you will, right?
Yes, that's correct. Right.
Because if I come with, let's say, you have a UPF and I deploy application blah, right?
Yeah.
And I will pretend to be the same labels, that service ID mapping. So it's actually global key values plus attested, so basically kubelet unique identifiers that identify a given entity. But then I think the let's say granularity is a container probably, right?
So I mean, not necessarily in the sense that, let's say I have an SVID 1 which gives out an SVID based on node name, right? So all the workloads on that particular node will get that SVID. Additionally, I can have an SVID 2, which is given out on the basis of pod name. So as Rahul was mentioning, so you can have a pod which gets one SVID based on the fact that it is running on this particular node, but it also gets another SVID based on the fact that it has a separate pod name, right? So you can, so it's finally based on the key value pairs, you can get different SVIDs. So how do we map it and how we use it? I think that's the key thing over here in terms of, what are the registered entries which we are going to populate. So that's the key over here.
Yeah,
So,
but what I'm trying to say is the following, right? Is that there needs to be some pieces or some identifiers that cannot be spoofed or cannot be
I know. So
taken, right?
yeah, I get your point. So basically, none of these can be spoofed, right? So basically, you have a pod name, which is basically namespaced in some sense, right? And then so you're getting these attributes, and these are
Yeah,
the
pod label, for example, I can spoof, right?
exactly right. So you can no. So
No, that's right. Yeah, labels can be spoofed. Anyone can set the labels whatever they want.
exactly right,
Is
right,
equal to
correct.
XYZ.
So you're going to have your registered entries. It's going to be some combination of verified attributes,
Yeah.
right? So
That's my point, right? It has to be a combination of, let's
exactly,
call it
exactly.
unique, or let's
Ex-
say kubelet assigned identifiers, plus
Correct.
some, that's what I call global indexes that you can map to, right? So it's basically a combination
it's
of
basically a
that, I
primary
think.
key, right? Primary key in
Yes.
databases, right? Yeah.
Okay, yeah, makes sense. Because otherwise, if I come, let's say, with UPF2, let's call it, right?
Yeah.
And I use the same pod label, and I use service ID pod label, I could
Correct.
get the identity of the other. But because I think the kubelet maps it also not only to pod name, but also to other unique identifiers, you will not be able to do so. That's my understanding.
Yep. So this list of attributes, I think there is a bunch of other things also which is there. So, but then this is just representative.
One more thing, if I may, right? So a pod can basically contain multiple containers. I'm assuming that the granularity of this is on a per container basis, or is it on a per pod basis?
So we have a container name in the attribute.
Okay. So I'm assuming, and these attributes are fixed, I guess, or these, so some of these need to be there, and then there will be some more flexible, I guess, right?
Yeah, so these are the set of attributes which are available. So we've got a cluster name, we have got an agent, we have got service account.
And they're always set or what?
Yeah, so the kubelet returns
flexible?
all this. Yeah, the kubelet returns this, but this attributes is fixed actually. So
it's fixed. Okay, yeah, that's what I thought. Yeah, it has to. I think the unique set of all of these needs to make it unique somehow, right?
yeah.
No, but attributes are extensible in the sense that tomorrow, if you want to make
Yes.
use of region as an attribute, additionally, let's say, for example, so you provide an attestation mechanism for that particular attribute. And that's what the plugin framework for attestation, this attestation plugin framework, like you can see, this is a plugin server node attester K8s PSAT, right? Like this is one of the plugin. So you can expand if you want, if you have your own set of attributes that you want to expand towards, it's possible to expand it.
But then you have to make your own
Yes.
attester,
Yes,
basically,
yes,
right? So
yes.
that's what you're saying. So there
Yes.
is predefined, and then you can have
You can add
extensions that makes it unique for yourself. Okay,
Yes.
that makes sense. But again, I think when you do so, what I'm trying to say is that it has to be the set of attributes needs to be probably a mix of global or, let's say, replaceable attributes, or that someone can spoof, versus things that are unique assigned within the cluster, I guess, right? So it will be a combination.
It has to be that way. Yeah.
Mm-hmm. Okay, sorry, I'll shut up.
Yeah. Okay. So moving on. So now we come to the nephew considerations part of for node attestation. Right. So as I was mentioning, so we need to have one Spire agent per node. So there are going to be multiple Spire agents which are running on, let's say, the workload cluster. We need to have, again, over here in the management cluster also, I mean, depending upon number of nodes, you'll have multiple Spire agents over here. And then here we'll have a Bootstrap secret. I've just used Bootstrap secret controller, but then it's only a placeholder for saying that, some functionality needs to get added. Now, I'm not sure. I've just put Bootstrap secret controller over here, but it could be anything. It should be some entity over here. So now coming to here, right? Now let's see the node attestation in Nephew, how that needs to happen. Now the Spire agent, when it contacts the Spire server, it needs to do it over a TLS connection, and the certificate for the TLS connection will come from this Bootstrap bundle. Right? So it will basically send across, it needs to, and that over the TLS connection, it will send across the PSAT, whatever we discussed, right? The projected SAT and all that stuff, but that needs to go over TLS. And that TLS certificates are basically this Bootstrap bundle, which I am showing over here. Right? Is that okay? Any questions over here?
So in other words, wait, so the secret controller needs to put the secret onto the workload cluster, right? That's what we are discussing. Is that correct?
Right, correct.
So it will use its own bundle, and then it goes to the Spire agent. And the Spire agent knows the identity of the Bootstrap controller, right? Because of I think, is it true that the Spire server or that the identities are somehow distributed globally?
In the sense that this Bootstrap bundle should also be, the Spire server, when there's a connection which happens to the Spire server, it should be able to use the Bootstrap bundle for the TLS connection.
See, yeah.
Right.
Yeah.
So,
Go
ahead.
The certificate, this trust bundle is shipped along with. So once the Spire agent attests itself with the Spire server is going to send the trust bundle along with the signed certificate to the Spire agent. This is the trust bundle that will be used in the future for certificate verification. That is what allows that will eventually allow this. That is what will eventually allow you to do identity federation, right? Like otherwise, What is it you're saying, Shiv?
Sorry, Rahul. So, but I think this is slightly different in the sense that, this is about the scenario where the Spire agent has not yet attested itself to the Spire server. So, if you come over here, I'm just trying to, sort of
okay.
See, even for sending the proof of identity, right? It needs a TLS connection.
Okay.
Right. So those that bundle is provided by the Bootstrap bundle.
No, but then how do we establish okay, so then the question is, turtles all the way down, right? Like where is that secure provisioning happening?
Yeah, correct. So that my point is like, how do we now we have a problem with the Bootstrap server, basically, right?
Yeah.
So so probably I'll sort of look at that and also reach out to you again for that particular thing. But then I'm just trying to lay out what are the overall requirements which are going to come out. I think we should be able to work out something in terms of generating a bundle and then sharing it over here, because so the secrets controller is also all in the sense that even if we need to think it out, but then I'm just laying out the thing.
Because the first problem that we have, Shiv, is how to get the Spire agent to run on the workload cluster. That's basically the role of the Bootstrap controller right now, right?
Yes.
What it's actually doing. Okay, it uses so at the moment the role of there is a secret part, and then there is the generic control, right? Because the reason we created it was and I think the secret, I think we probably can solve in a different way, right? So the first problem that we have is in this picture, how do we even get the Spire agent to run?
So that will be the packaging aspect, right? It should be a
no, but so the way we do it right now, right? There is, besides the Bootstrap secret controller, there is a Bootstrap what do we call it? I think there is a Bootstrap
controller.
yeah, Bootstrap controller, and there's a secret one, right? So they're two separate. But the Bootstrap one takes a set of packages that we put into a separate repo, which we call staging.
Okay.
And at the moment we put, I mean, we will put the Spire agent probably there, right? And what it basically applies it through the kube config. So it takes the kube config that cluster API spits out.
Yep.
And applies and uses that to actually install the Spire agent.
Right.
Right. Now, if you look at that, because that's where we have a bit of untrust, I think. So but let's assume that we can figure this out.
Yep.
Would we not do the secrets in a different way, the other way around? Would we not have, as part of that bootstrapping, a piece of software that we basically put onto the workload cluster and basically pulls the secrets from the workload cluster, rather than now push it down? Is that not more safe?
So
in other words, I would put the Bootstrap secret controller on the Spire agent on the workload cluster. You attest it on the workload cluster to say, okay, I'll assign an identity to it, and then it will be known into the system, and then by doing so, we give it the right access rights to be able to get the secret from the management cluster down to the workload cluster. I'm just thinking out loud.
Yeah. So I get your point. So basically for that, right, you need to have some tokens for the workload cluster to access the management cluster.
Yes.
Right. It's going to be API call, right? In terms of get secret, yes, or something like that.
Correct.
Right. So so you need to push some tokens. That's my point. So if you're pushing that, you might as well push because you have the kube config over here, right? With the Bootstrap controller. That Bootstrap controller can basically, it has a kube config. It will create the Spire agent, and it will also push a certificate bundle, in that particular as a secret over here.
Mm-hmm.
All right. Now it's going to be in the same. Yeah, we need to think this out. I think, yeah, I'll just note that point and
So, but what you're basically saying is that the Bootstrap bundle will have to be pushed at the beginning for the Spire agent to be able to do its job, right? So that's where we have a
Correct. Yeah. Right. We need to, think through the aspects. But the thing is that once the attestation is done, the further TLS connection will happen over the SPIFFE SVI ID. Yeah. So we don't need the Bootstrap bundle after that, after the attestation is done. Yes. So
yeah, let's keep this as an
work item. Yeah, sure. Okay. So that's one part. So that's basically the pushing the Bootstrap bundle and then establishing the TLS connection. Now this is the other aspect. Basically, because the Spire server, right, needs to do a token review with the workload clusters API server, if you remember the original diagram, right? Now, for that, the Spire server needs a token, and for doing the token review. So that I'm creating a set of workload as a secret, and then writing it over here, and then the Spire server reads it from here. And the big difference is with this particular service account token, we can only do a token review. So that's the cluster using the role binding will ensure that whatever role is there, which this particular workload cluster gives out, that's basically only going to, you can only do a token review and nothing else. So that way it's safe to keep it as a secret over here. But that's what. So does this sound okay?
So yeah, so this is basically just for the This is a secret for token review purposes, right?
Correct. So previously, if you
And should this,
see, in the last week's diagram, I had kept a kube config over there. And that was your feedback, right? So because the kube config,
yes.
you have to be really careful because it's, not secure. And so, I mean, we cannot just, have all the entities cannot have access. So we sort of discussed and we felt that, having a secure a service account token, which does a token review, so that we can use that instead of a kube config.
Mm-hmm. Yeah, that makes sense.
So,
and that will be rotated in theory, right?
Yeah, we should be able to do that because it's on a per cluster basis and it's not on a per node basis, and we need to build that logic. Yeah.
Mm-hmm.
Okay, just a quick time check.
Yeah.
8 more minutes left. Maybe we can. Is how many more?
So I'm sort of done in the sense that I think this is the main. So this is basically only a repetition of whatever is the diagram it shows, and I wanted to show basically. Yeah, so I mean, there's some work items in terms of so previously I had shown a configuration like this, right? Yeah, so that the server configuration, it needs to have a, the path to the, service account token. But this is slightly incorrect. The actual configuration is, it has a kube config file, right? So we need to make this change in the Spire server, basically that instead of using a kube config file, it needs to use a, the special token from secrets to access the token review API. So this is getting into details, as to what are the work items and, what changes we might need to do.
Hey, so Shiv,
Yeah.
I think for PSAT, right? Like there are some other assumptions as well, right? By default, it is not enabled, right? Like the projected tokens are not enabled by default, the Kubernetes clusters.
Yeah, correct. Yeah. So Rahul, actually, we want to try that out. So right now, Prashant
Okay.
is trying it out, and we'll have more data on that thing. Probably we should be able to confirm by next week.
Cool.
Yeah.
Cool.
So, right, and so this is how we want to use SVID to access secrets. I'm just leaving it for now because we just want to focus on the identity part. So I think I'm done. Rahul. Yeah.
Thank you, Shiv. Really appreciate. Thank you for this preparing on this presentation. Any questions? We have 5 more minutes. Or any other topic that we need to discuss? So I wanted to ask Byung, but he has dropped off about the user identity part, right? Like what is the next action item there? But since he has dropped off, yeah, I think I'll have to follow up on Slack. If nothing else, we can wrap up the meeting. Thank you, everyone. Thank you very much. Have a good day. Good week ahead.
Thank you.
Thank you.
Yeah. Thank you.